Alright, we've got this set of numbers, and we're asked to figure out which two can be removed so that the arithmetic mean remains unchanged. So, well, let's first of all just figure out what the arithmetic mean is. I'm just going to add up all these numbers and then divide it by the number of numbers. That's what an arithmetic mean is. Some people call it the same thing as an average, okay? Same thing as an average. So, let's add these up. I'm going to take a couple of these that look convenient because I know that's 30. And 17 and 13, that's 30. And then we have 10, so if I take that along with these two, that's 70. And then, let's see, what have I got left? I've got the 5, a 9, and a 12. 14 and 12, that's 26. So it looks like the sum is 96. And I have 1, 2, 3, 4, 5, 6, 7, 8 numbers. So if I divide 8 into 96, I get 12. Alright? So the arithmetic mean of this is 12. And okay, we need to figure out which two numbers can be removed so that the arithmetic mean remains unchanged. Now, the short answer is that you need to find two numbers that add up to 2 times 12. Okay, if you remove that, you'll get the arithmetic mean of that reduced set will be unchanged. Some people think, well, that's just obvious. I suppose if you think that, so if this happened to be 8 12s, okay, if you had a set that looked like this, 12, 12, 12, 12, 12, 12, 12, 12, obviously the arithmetic mean of 8 12s is 12, right? And if you moved two of them, you'd still have an arithmetic mean of 12, okay? So you could reason it out that way, that as long as you take away two 12s from a set that where the arithmetic mean is 12, then you'll still get 12 as the average. Another way to think of it is that the arithmetic mean just means that you add up the numbers in the set. I'll just call them A1, A2, A3, and so on. And let's say that there's n numbers in that set. Let's actually call that AN. Okay, because these are the actual numbers in the set. So this is the nth number in that set. We divide it by the number of numbers, and we get the average. I'm just going to call it A. So the sum of the numbers, A1 plus A2 plus A3 up to, let me make it a dot 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 because we don't really know how many are in here. AN is equal to n times A. All I've done is just multiply both sides by n. Okay, so if I were to, let's say we were going to remove two numbers from this set. Okay, if I remove 2 times the average from both sides, okay, I end up, that's 2a, not 24. It's 2a. Then I can rewrite this as n minus 2 times a. And then, so you can see if I remove two averages, in this case it is 24, but if I remove 2 times the average from this set and divide it by n minus 2, then I'll get the same average, right? So A1 plus A2 plus dot 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 plus AN minus 2 times the average over n minus 2, n minus 2. You can cancel that out and get the same average. Okay. So anyway, that's the explanation of why we need to remove 2 times the average. And so let's just look at the numbers and try to find two of them that add up to 24, because that's 2 times the average. And when you look at these, and just by trial and error, you'll see that 10 and 14. All right, so that's this one and this one will add up to 24. And so if we remove those two, we will get the same average. Okay, so we'll only have 6 numbers. So if we add up the remaining numbers and divide it by 6, now we'll get the same average. We should get 12 again. So the answer is that 10 and 14 are the numbers that we can remove, and the average remains unchanged.